Hello everyone. It's a lovely day up here in Scotland. The sun is shining, the air is chilly. Let's do some programming. To give a brief recap of where we are, we're solving Advent of Code. It's a programming competition. Well, it's a programming competition of sorts. Every day of December from 1st to 25th, a new problem is showed. And then we're solving it on the day as they come out. We've done the first 5 problems so far, and today we're going to be doing the 6th. Now, Advent of Code is, well, I call it a competition, but I'm doing so in air quotes. It's not really, well, some people definitely play it for speed, to see who's the best at it, but most people just use it as an opportunity to learn something new. For me, that's streaming and programming things in Elixir, and specifically in Livebook. Livebook is this lovely little Elixir app. Well, it's a web app. It lets you write a little bit of code, and then it executes it. And I find that this makes programming in it and exploring with it very, very pleasant. I also suspect it's pretty good for streaming, since you can see what's being done as things go on. Now, Livebook is also fairly sophisticated. It lets you do funny things like create a text area, and then it actually generates a text area rather than just evaluating the code. And then you can read the input from the text area with something like read input. Yeah. If you've ever seen Jupyter notebooks, this is kind of like that, but less featureful, but much sane, much better. Livebook has very few gotchas when it comes to evaluating code, which is the key thing that I want. Now, Advent of Code. So far, we've gotten launched out of a trebuchet, played a game of colored cubes with an elf, helped another elf fix his gondola machine, helped another elf compute his scratch card winnings, and you're not going to believe this, but then we helped another elf avert a famine on his island. Yesterday's question was, well, my solution to yesterday's problem was not nice. Like, here it is, and it's definitely the worst code I've written for Advent of Code so far. The problem itself isn't that bad. You're basically given a list of numbers, and then you have to pass each number through a series of arithmetic transformations. Now, the transformations themselves aren't hard, you can just do them. They're basically based on ranges. You pass 79, and if 79 is between 50 and 98, then you have to add 2 to it, and so on. The first part of this problem was actually really easy to solve. Yeah. The second part, however, was pretty horrible. The main thing that changed was that instead of just having to pass, say, 4 numbers through this series of transformations, we had to pass billions of numbers. So this input essentially says, here, we have, what's that, 160 million numbers to pass through this transformation. And here's another 0.6 billion, and another 0.7 billion, and so on. Now, I looked at this, and I immediately thought that this can't be brute forced. But really, that was my competition programmer training. In competitions, you normally have to solve every problem in under a second or so. So just evaluating a few 100 billion things is not feasible. But then I actually checked online, and turns out it was feasible. It's just that it would have taken something like 7 to 30 minutes. And really, if we had done this in Elixir, we could have done it a lot faster, because we could have parallelized this trivially. But we didn't do that. We instead solved it properly, which was... yeah, it was very involved. This code was tricky to write, and it would be a nightmare to debug if it didn't work. But luckily it does work. Anyway, I think the lesson from yesterday is don't discount the brute force solution, because letting it run for a minute is completely acceptable in the context of this competition. So, without further ado, let's go and see what day 6 is about. Day 6. Wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry has docked. Oh, we're looking for sand here, by the way, because we need the sand to filter the water so that we can fill the snow machine with the water. This whole thing is a massive scavenger hunt. As you try to figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races, open to the public. Grand prize is an all-expenses-paid trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. So it lists the time allowed for each race and the best distance ever for that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. Okay? So I guess this is our constraint, and the time is our constraint, and the distance is the number we have to exceed. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time. You can only hold the button at the start of the race, and boats don't move until the button is released. For example, so the time for each race... This document describes 3 races. The first race lasts 7 milliseconds. Oh, this is really fast race. The record distance in this race is 9 millimeters. This is also a very short race. The second race lasts 15 milliseconds and the distance is 40 millimeters. The third race is 30 milliseconds and the record distance is 200 millimeters. Right, so we have the time in milliseconds and the distance in millimeters. Your toy boat has a starting speed of 0 millimeters per second. For each whole millisecond you spend at the beginning of the race holding down the button, the boat's speed increases by 1 millimeter per second. So because the first race, technically the speed doesn't increase at all because you're still holding it in place, but I get what they're saying. So, because the first race lasts 7 milliseconds, you only get a few options. Don't hold the button at all, that is, hold it for 0 milliseconds at the start of the race. The boat won't move and it will have traveled 0 millimeters by the end of the race. Hold the button for 1 millisecond at the start of the race, then the boat will travel at a speed of 1 millimeter per millisecond for 6 milliseconds, reaching a total distance of 6 millimeters. Hold the button for 2 milliseconds, you get a speed of 2 millimeters per millisecond. It will then have 5 milliseconds to move because we have 7 minus 2 is 5, and then it will reach a total distance of 10 millimeters because it will be moving 5 milliseconds at 2 millimeters per millisecond. So the boat doesn't slow down. Okay, hold the button for 3 milliseconds, it will have gone for 12. 4 is 12, 5 is 10, 6 is 6, 7. Hold the button for 7 milliseconds. That's the entire duration of the race. You never let go of the button. The boat can't move until you let go of the button. Please make sure you let go of the button so that the boat gets to move. 0 millimeters. Since the current record for this race is 9 millimeters, there are actually 4 different ways you could win. You could hold the button for 2, 3, 4, or 5 milliseconds at the start of the race. How did they even get 7 millimeters? That's not one of the valid answers. The elves are definitely cheating. Like, it would be trivial to just knock the boat a bit forward when releasing the button, and you only have to knock it a few millimeters. In the second race, you could hold the button for at least 4 milliseconds and at most 11 milliseconds to beat the record. A total of 0 different ways to win. Oh, that's interesting. So this causes a bit of humped graph, kind of like a normal distribution, but of course unlikely to be a normal distribution. Maybe this is a combinatoric thing? Maybe this is a binomial distribution of some sort? We'll see. In the third race, you could hold the button for at least 11 milliseconds and no more than 19 milliseconds and still beat the record. A total of 9 ways you could win. To see how much margin of error you have, determine the number of ways you can beat the record in each race. In this example, if you multiply these values together, you get 288, 4 times 8 times 9. So it's 4 different ways times 8 different ways times 9 different ways. Determine the number of ways you could beat the record in each list. What do you get if you multiply these numbers together? Okay, and what does the full puzzle input look like? Oh, the full puzzle input is literally 4 numbers, 4 races. But the numbers are largish, aren't they? I mean, the numbers are largish, but this is still... You can just calculate this manually, can't you? Because we can do something... I bet this is solvable with some clever maths. Probably not even that clever. But we can also just solve the problem manually. We just have to do one evaluation for every possible for every possible length of time we could hold the button down. And since we can only hold the button down for a whole number of milliseconds, even in the full input, we'd only have to compute 38 values here, 94 here, so total of maybe 300 values. And then for every one of the 300 values, we just have to compare against this number. Okay, let's do this manually. Let's not be clever. And then we'll see what part 2 is all about. Right, so we're solving this in Livebook. We create a new notebook for this problem. This is going to be called AoC 2023 Day 6. Let's save it so that we don't lose everything if Livebook crashes. I do this every day and it's never actually crashed, but better safe than sorry. Okay, we're going to need Kino as a dependency because we're using it to read the input. First section is called helpers, like always. Then we're going to have 2 inputs, one for the example and one for the full problem. Kino input text area. This is called example. Right, so calling Kino input generates an actual text area we can read here, and then we can later read the value of this text area with Kino input read. And here we're going to call this full. It will be Kino input text area full input. Right. Next we need a new section. This is going to be part 1. Yeah. And in fact we should copy our input now. I was trying to switch tabs with key bindings, but that doesn't work. I'm not dexterous enough to do that. Okay, so now we have our example and full input. So first off, we need to do a bit of parsing to get the race time and the race distance. And that's going to be really easy to do. Yes. Kino input read example. So this gives us the input as a string. Next up, we're going to split it on lines. Yep, let's just add an extra new line here. And oh look, there's a trailing empty list there, and a trailing empty string there. So let's also trim the input to get rid of the extra string. I'm doing this because I noticed that the full input has a new line at the end based on how I copy-pasted it, and I didn't want surprises later. Right, now we have two of these lines. So we need to map over them. For each line, we're going to first we're going to split on columns. Then we're going to get everything except for the first element. So this gives us the actual lists we want. Next up, we split on spaces. No function matching string split. Oh, because I gave it a list instead of an element. So here, I don't really want tail. What I want is fn. I don't care about the first thing. I care about the second thing, nums. Okay, now we have the split, but there's lots of empty strings in there because there were lots of extra spaces. So we trim this, and now we get the two numbers. We get the two lists of numbers. Next up, let's convert these to integers, because we're going to be doing arithmetic on them later. And here I'm using Elixir's shorthand for referencing a function directly, as opposed to just creating a closure manually, like here. Okay, now we have the two lists. Do we have? Yes, we have the two lists. Now this is kind of what we want, but really we want to pair up 7 and 9, 15 and 40, 30 and 200, because that's how the input works. Like this is the data for the first list. So to do that, we're just going to unzip. It's not called this unzip. Is it a num unzip? Almost. Oh, we have... Right, and how does unzip actually work? Can I call it here? Let's comment this out. This runs now. What does an unzip actually take? It does take a list. Oh, I want zip, don't I? Yeah, I want zip, not unzip. Yes, good. Zip is the operation that takes the first element of each of the two lists and returns it as a tuple. Then the second element of each of the two lists and returns it as a tuple, and so on. Okay, so now we have our parsing done. We pipe this into an enum map again, because each of these is going to be a separate game. So we have time and record distance. And now the question is, for each time and record this, for each time, right. Okay, let's do this. Let's not care about record distance for a moment, and let's just look at time. We have, I can close the input here. Okay, now we have a time. We want to try, I said we're going to do this manually, so we're going to go over every possible, we're going to try holding down the button for all the possible times, which in our case is going to be 1 through time minus 1. Right, so for the first race, the only amounts of time it makes sense to hold down the button for is 1 through 6, right? Because 0 never makes sense, and 7 never makes sense. So the only ones that matter, that make sense, are 1 through 6. Okay, if we hold it down for, say, 3 milliseconds, we then have 7 minus 3 milliseconds of race time, of travel time remaining. Okay, so enum.map. Everything has enum.maps if you squint hard enough, unless it's a reduce. Yay, morphisms. Okay, so time button held down. Let's just call it time button. Time button held. Then we have time to sail. Yes, time to sail, and this is going to be, right, let's call this race time. Race time minus time button held. And our speed is equal to the time the button was held. So this is just going to return time to sail. Let's just write it out and then we can code golf this. Time button held. And then time to sail is time to sail times speed. This is the distance, this computes the distance we can travel in this race if we hold the button down for this long. So, for our first race, it should be 6, 10, 12, 12, 10, 6. And yeah, this looks very combinatoric. Alright, so it's 6, 10, 12, 12, 10, 6. Yep, so we're computing this correctly. Now the question is, how many of these exceed the record distance? So num.filter, we're again using the shorthand here. Well, we're using the shorthand to define a closure this time. So we just want all of the values where our distance exceeds the record distance. And I'm going to check in a second if it has to be exceeds or equals. So, your toy boat has go further in each race than the current record holder, so it has to be strictly exceeds, so this is correct. And now these are the distances we can travel in order to exceed the current record. Now, it's displaying this one here as a char list because the numbers are low enough that they look like plausible ASCII characters, so Elixir is looking at the whole list and guessing that it's actually a char list, so it's displaying it like this. But we can just circumvent that by including more information. So let's include time button held here as well. This is... Should we? No, we don't actually care about this, because really all we care about is the length. No, just length. Okay, so we have 4, 8, 9. 4, 8, 9, and then we have to multiply these together. So I'm assuming that's going to be called enum.product. Enum product 288. Yep, this looks right. So let's try this on the full input. Yep, we get this number. We submit. Okay, that's the right answer. We have 1 gold star. Let's see what part 2 is about. This is worryingly short. Alright, let's go. Part 2. As the race is about to start, you realize the piece of paper with race times and record distances you got earlier actually has very bad kerning. There's really only one race. Ignore the spaces between the numbers on each line. So, the example from above now instead means this. Lovely. Now you have to figure out how many ways there are to win this single race. In this example, the race lasts for 530 milliseconds. And the record distance you need to beat is 940,200 millimeters. You could hold the button anywhere from 14 to 71,000-ish milliseconds to beat the record. A total of 7,503 ways. How many ways can you beat the record in this one much longer race? This is still iterable though, isn't it? So what's the full input going to look like? The full input is going to be an 8-digit number. An 8-digit number is like 38 million things. Yeah, we can absolutely iterate. We can absolutely iterate through 38 million things and do one multiplication each. 38 million multiplications is going to complete very quickly. All right. This is looking to be a very easy day. But let's see, maybe there's a catch that I haven't seen yet. So let's just copy everything. Let's switch back to the example. And we have the answer as before. So now the only really interesting thing is that we have to tweak our input a bit. So let's comment out the actual computation. That's the original input, but we actually want to concatenate these together. So here, where we do string split, we're just going to do an enum join. And then here, we don't have an enum anymore, right? So now we have 71530. Where is it? 71530 and 940, 200. 940, 200. Okay. So now we have despair. Despair sounds a lot like despair, doesn't it? But hopefully we won't have to despair. Let's just turn this into a tuple. First argument is not a list. Right. This has to go here. Right. Then we don't have a zip anymore. We can uncomment this. And here, we're not doing a enum map anymore. We're just doing then. And we don't need a product at the end. Okay, and I just ran it and it evaluated, and the answer is 71503. 71503. And how quickly did it evaluate? 0.3 seconds. And it's always 0.3 seconds, so I suspect this is just the startup time or the evaluation time for the interpreter. Okay, so let's try it on full and see what happens. This is taking longer than I expected. Why is it taking longer? So let's have a look. We are currently going through 38 million... Is it? Yeah, it's 38 million numbers here. And then we evaluate just... Yeah, this is 1 to race time, so this is 38 million. Then every one of the 38 millions, we just do one multiplication. And then we do a filter, and then a length. This should not take this long. Can I stop it? I can't stop it. All right. What shall we do? Okay, let's do this. Let's try to be clever about this. I've been meaning to try this out for a while. Let's say progress here. Kino frame? Yes, Kino frame, I think. Okay, now we have a frame that we can write into. And here, we're just going to do Kino frame render progress time button held. And now when I evaluated this, we should see the number it is currently processing there. In fact, instead let's just have some more numbers here. Time button held out of race time. Yes. Oh wow, this is shockingly slow. I guess the just-in-time compiler isn't actually running for a livebook. Let's just make sure that we're not breaking this with the actual rendering. Maybe just the rendering is slow. Ah, it is slow, isn't it? Yes, it really doesn't like rendering lots of things, I guess. Because this keeps going because this hasn't actually stopped properly. Right, because the way this is Elixir, so likely the way this works is that this is actually a process, and we just flooded that process's inbox with a lot of messages. And then it had to, in order to process a message, it had to actually display it as HTML, which was probably a lot slower. Well, so I guess we're getting punished for being clever. But, well, live and learn, live and learn. Time held mod. Is this the syntax, I wonder? Is it saved? Notebook saved. Has it stopped? Finally? It does not look stopped. So, can I just restart this? Will that actually kill it? Or do I have to restart the whole server? Up. Yeah, it's still running at full speed. Okay. Well, so now we learned. We do not flood livebook processes with lots of data. And it doesn't want to terminate because it's probably trying to do this nicely. Okay, that's a different process. That's a different PID. So yes, it restarted properly. Now let me quickly get my password for this. Okay. Open day 6. And it didn't even save the very last thing we did. Yep, that we managed to completely crash it there. Okay, is it mod or is it %? 2 and syntax error before do. So presumably it's mod. Undefined time button held. Elixir modulo operation. And I have actually searched for this before, apparently. REM. It's called REM. The following arguments were given to... What line is this? This is 12. It lost the input. Of course it did. It lost the input because we restarted. and we don't save the input. Right. And we're going to test this on the example first. Let's not do it on the full one. Okay, this was pretty fast, and we didn't overload the output. So now we try the full one as well. Full. So last time this went poorly. Let's see how bad it goes this time. Okay, this is slow. Yeah, I would have expected it to do on the order of millions of operations per second, not... Wait, is it still having trouble rendering? Oh, god damn it. Yes, it is. But still, this should nonetheless terminate, because clearly it's getting there, so why did it not terminate? Okay, let's display even less frequently. Now let's just let it run to completion. And after this, we're going to figure out why it's so slow. Oh, did it hang there? It paused there for a second, and I don't know why. Is it because it's generating a massive list? Yes, because we're generating a massive list here. That's what's going on. Okay, we can fix this. So first off, we switch back to the example. And then instead of enum, we're just going to use stream here. And even the actual web app is sort of slowing down now because it's probably garbage collecting like crazy. So, okay, so here we have to do another stream to list, presumably. Stream to list is undefined. What is it that we can do with a stream? A stream is kind of like a list, but it's lazily evaluated. Oh, we don't actually need to do this, do we? We just have to do count. We want list count. That's what we want. Enum count. Because enum count, if I remember correctly, returns the size of an enumerable. No, we still need a filter. Okay, we need stream filter and then enum count. Okay, can we just do this? Surely a stream is an enumerable. Okay, this was way faster. This doesn't feel particularly faster here, though. And it's still hanging. Wonder if I can see runtime settings. Yeah. So here we can see if this is actually allocating a lot of memory. Doesn't look like it. So maybe it's just incredibly slow. We're going to try to put the enum count earlier next time. Let's just get an answer first, because this should actually terminate. But we're already at 10 million, we just need to get to 40 million. Yeah, and we're still just using 32 megabytes of memory, so we're definitely not going to overflow or anything. And this will take 4 minutes to compute, which is way too slow. My model for this is usually that a modern computer can do around 100 million operations per second, where operation is some sort of ambiguously defined term like an addition, but probably not a multiplication, or an addition, or maybe a memory access and so on. Although, of course, not all memory accesses are equal. But still, 100 million operations per second is a pretty decent approximation of what actually happens. Now we have a lot less than 100 million operations here, right? Because we're just doing one multiplication and one comparison for each of these numbers. So really, this should complete in under a second. 4 minutes is way, way too slow. Yeah. We're going to debug this. And after we make this fast, I guess we could have a look and see if this is actually just the combinations or something, and then we can apply the mathematical formula and be done with it. Almost there. Just got 7 million more to go. Come on, just 2 more million. Yay. All right. Is this the right answer? Oh, it's really unhappy. That's the right answer. Okay, we have completed day 6. Can I just reload this and yeah, now it says we're done. Okay, we don't need the input anymore. Here we triggered an annoying Livebook bug or a Wayland Firefox Livebook weird interaction. So we have to reload to get it back into a good state. So now we're here. Why is this so slow? We should be able to get this to under a second. Surely we can get this to under a second. Okay, so first off, let's just fuse the comparison and the multiplication here, so that we don't have to worry about an intermediate list being generated. So this record dist. Okay. Now instead of stream map, we can do a num count, I believe. Num count. And we have to run this on the full input because the example input terminated quickly even last time. Okay, it's running, it's still slow. Livebook optimization. I wonder if anyone's actually asked any questions about this. People have not. Can we use something like Explorer? Probably not, because Explorer requires us to actually generate the data, and that we want to avoid generating the data. Just to make sure we're not screwing anything up. For the next run, I'm going to make this output even less frequently, just to make sure the output isn't what's slowing us down here. It shouldn't have been, because 100 messages, a few thousands of messages shouldn't have been a problem, but maybe they were. And I should have checked how long it took the first time to run to see if we're doing any if our changes are making it any faster. Okay, so count is going to take how long? Actually, I don't need to keep track of this because the thesis is that this should run in under a second. So anything over a second really is unacceptable. If the fact that we got it faster, the fact that we got it down from 5 minutes to 4 minutes is not really interesting to us. Still going to let it run to completion though. What does the documentation for enum count actually says? Returns the count of elements in the enumerable for which fun returns a truthy value. Is there a string.count? There is not. Okay, 2589. 23589. 23589. So we haven't broken it. So now we run it again. This time it's just going to be updating the progress a lot less frequently. So now it's definitely not the message passing that's slowing it down. And indeed, it wasn't the message passing. So what's going on here? Is it perhaps too stupid, and is it allocating... Is it perhaps not smart enough to optimize these away? So stop it. Let's inline this. Actually, probably the easiest thing to test out here would be to just run it outside of Livebook and see if Livebook is actually the problem or not. Yes, let's just quickly do that. And it won't even be hard to do. Okay, so here's my little Livebook folder, and we have all of the solutions, including day 6. This is what we've just been writing. Actually, let me get OBS visible on my code desktop as well. Can I make it increase text scale increase? Yes, all right. Now this is horrible to read, of course, because, well, it's technically just a markdown file. But so we're going to copy it into an Elixir file. This looks much better. We don't need the Kino thing anymore. Yes, we are instead, actually, we're going to replace the Kino thing with a simple IO_put_s. Right. And here, instead of Kino input read, we're just going to write the text manually. So what does our full input look like? Yes. Just to make sure nothing breaks, let's comment this out. Why can't I comment things out? Where's my... Yeah, it's... I was pressing the wrong key somehow. Okay, so now we have an Elixir file with our input, and it should just do the splitting. So here, if we go into Advent of Code 2023, we should be able to start an IEX. I don't have Elixir here. No worries, this is Nixos, so I can just do this. And it will give me an Elixir shell. Okay, now I have Elixir. Is this how you load something? Day 6. Help. Help. Compiles a file and writes the bytecode. No. Prints information about the last value, so it's not I. It's... how do I load something? You can also use the I function to inspect the value you have in the shell. Surely there's a way to import. List, flush, clears, changes, compiles a file. Maybe compile is what I want? Day6.ex. Syntax error before time. Oh, okay. Does Elixir have 3? Yes, looks like it. The following functions were given to string split. What version of Elixir are we on here? This isn't some horribly... no, it's 1.15. The following arguments were given... oh, this is a char list. Oh. So do we have string from... no, it's list to string, or... yeah. So here I want list to string. Is this going to work? Yes. Can I now actually call the function? Probably not. How do I evaluate? How do I evaluate? Oh, I probably just need to run IEX day 6. That didn't do anything. Do I need to pipe this into IO inspect? Yes, okay, so now compiling this file causes it to output the values, which seem large. That's fine. Okay, now I'll inspect here. Yeah, see, this was fast. This is what I was expecting. But when I run it in Livebook, it's, well, to put it mildly, it's slow as shit. Why does it take 6 minutes? Why does it take 4 minutes to run in Livebook, but is absolutely instant when you run it in IEX? Okay, Elixir Livebook, very slow. Performance issues. Performance issues after Elixir upgrade. I doubt this matters, but this is relevant. But maybe somebody has something to say here. Okay, this is some database thing. This is not relevant. What information do we have here? So it's OTP 25. It's JIT NS. What does JIT NS mean? Or rather, what is Livebook currently running on? That's user profile. Where's my settings? Elixir 1.17.7. Elixir 117.7. So it's the same one. It does have, it's also Erlang 25. It's also SMP 88, so this presumably means it's running 8 schedulers for 8 cores. Async threads 1, not sure what that is, but it's unchanged. JIT-NS. Slower than IEX. So the trouble with using something shiny like Livebook is that everybody is just praising it instead of complaining about the bad speed of it. Why is Elixir code so slow? This is probably too old. Okay, let's see if we can find a better example. I'd like to open a bug or ask a question about this, but I don't want to give them the whole day 6 problem. So let's start a new block. Let's call it speed debugging. Okay, and now the thing that's slow basically is 1 to, let's say, 30 million. enum.count fnx or fnn. Let's race time minus. Right. And let's just quickly here say n is equal then. There's also multiplication here. Maybe the multiplication is the slow bit. We'll find out. So n greater than 20 million. So this should be fast. Stop. So evaluating this one causes it to evaluate that one. That's okay. We can just fork this from the helpers, and now it won't evaluate the previous section. Right. This is slow. This should not be this slow. Right? If I copy this, then here go into create speed debugging.ex. Well, this was still faster than before. Took only 15 seconds, but I suspect 15 seconds is still way too much. So where's day 6? The other day 6. Here we go. Then we copy this into its own file. Okay, and now here I'm going to run speed debugging.ex. Yep, that was pretty much instant. Do I have a timing function? I do not have a timing function. I just add an IO inspect at the end of this to make sure that it's actually running. Yep, it's running and it's more or less instant. Reload this to get Livebook back into a good state. Okay. And now if I do a multiplication here, is it going to be even more slow? This is a large number, but surely it fits into a 64-bit integer, right? What's integer? Max? Elixir max integer value. What does the max integer value look like? Integers in Elixir, Erlang Elixir are only limited by the memory available on a system. Oh, that's interesting. Elixir uses big num arithmetic. Oh. Well, that would explain why it's potentially so slow. But if that's true, can I just cheat? What happens? No, this is... So that would explain why the multiplication here is so slow, if it's using actual big num arithmetic. Because my hypothesis was that or my claim was that it should do 100 million operations per second. But this was clearly doing much less than that. But if this is actually just doing big num arithmetic, and specifically if it's not using some actual library to do it, then yeah, it will be a lot slower than that. But even ignoring this, this shouldn't take, just iterating over numbers like this shouldn't take 16 seconds. Let's try something else. I wonder, is it just always so slow, or is it just something to do with the list? So let's do a tail recursive function. My count. And you give it a number, and if when n is less than 30 million, what do we do? Oh, and we also need an accumulator. Then we are going to do my count of n and accumulator plus 1. So if n is greater than 20 million, don't even need to bother with this. Let's see how fast this is, and then let's see if this is sufficient. Let's see if even not having the comparison is enough to cause the slowdown. Right. And my count, when we get to a number, an n that is over 30 million, we're just going to return the accumulator. I'm just going to do my count of 1. And this should return... There's no my count, of course. I have to call it from the module. My count 1 is undefined. Yep, let's just do here my count n, my count n, and 0. Actually, we're just going to call this without any argument so that we don't have to say 1 every time. So this should take 14 seconds based on the experience of the last one, but it should take a lot less than 1 second. It's taking even longer than 14 seconds. Elixir Livebook JIT. Is the JIT even running for this? Oh, this is super slow. So, am I insane in thinking that this is actually supposed to be fast? Oh, this is actually slower than the list one. Today I'm learning all sorts of things. Okay, how slow is this actually? If ram n. It's not slow. I'm failing to add +1 here. Of course, I'm failing to add +1 here. Okay, this looks faster. Now I don't want the printing anymore. Yep, and this was basically instant. Yes. Okay, back to Livebook. Reloading the page. Here. I forgot to do n+1. Well, we're getting to see the top one run again. This took 14 seconds last time. And this was instant. Look at this. Bam. Okay, so the tail recursive function worked fine. The count was somehow not optimized. The enum count was somehow unoptimized. Let's double check that we're not going crazy. We comment out this, the thing we just wrote. Now we do the count again. And the count is still like super fast in IEX. Yes. Okay. So we have something that's a bit more like a smoking gun. Let us simplify this further. Well, this still has a comparison here. This does not have a comparison here. Let's do a comparison here and see if that's what's breaking it. If n is greater than 20 million, else I count n+1, but we don't increase the accumulator. Yep, like this is instant. This is how it should be. And I should do equal, greater to or equals here just to be sure. Okay, so Livebook is slow, and I don't understand why. Where can we ask a question about this? Does Livebook dev have a discussions page? It does have a discussions page. Let's just quickly check. Are there any pull requests about this? Doesn't feel like it. Are there any speed? Can we speed up initialize of remote? Nope. Let's search speed. Can we speed up LLM integration? Nope. Optimize? That's probably enough. Nope. Speed again, but we look at closed issues. Putting 3 Livebook apps. Alright, so there's no actual pull request. There's no issue about this. Is there a discussion about this? There are no matching discussions. Most helpful. Joe says the most helpful person, which is unsurprising. Optimize. Nope. All right, so we go to discussions and we open a discussion. Why does question and answers? Ask the community for help. Ask about anything related to Livebook. Ideas, integrations, show and tell. Livebook is slower than Livebook seems slower than IEX. So, hi, I'm solving advent of code in Livebook this year, and I noticed that evaluation Valuation in Livebook is much slower than in IEX. A simple example is, here's a simple example. Here's a simple example. We don't need this anymore. We don't need this anymore. Here. And we can copy this from here. So this in how do I even time the IEX run? Can I run IEX and then end? Let's dash F. Boot var boot. Evaluates the specified expression. Oh, I'm starting to remember things. I'm starting to remember Joseph saying something about this. Wait. So this is slow as shit. This is what we're trying to fix. What if we put this in a module? Def module speed and def my phone speed test. So this is exactly the same thing we had before, except now it's in a module and a function. What if I do speed test? That's it. God damn it, I've forgotten about this. So Livebook doesn't actually optimize code unless it's in a module, which makes sense because the interpreter can only really compile and bycompile something if it's in a module. We're still going to start a discussion, but now we at least have an answer. So this was our solution to the problem, and it's slow. But we're going to make it not slow by putting it in a module. That module part 2 do. Then the function is just going to be called solve. It's going to take an input as an argument. Here's the input. Then it ends, and then it ends. Yep, and this one has too many. And now we are just going to call part2.solve a full. And this took something like 2 minutes before, but I claim it should be much faster. Why does it not have access to progress? It doesn't have access to progress because progress is now at the top level. So we feed progress here as an argument. Can I match on, progress? Is that the name of the struct? Yep, and binary and input is binary input. Okay, Kino progress is not the name of the struct. Kino frame is probably the name of the struct. Undefined variable progress. Yep, I mistyped it there. Oh, input is not actually a binary, it's a Kino input. Kino input. And yep, 2 seconds, which is more than I'd expect, but actually reasonable. It's not the insanely slow anymore. Okay. All right. There should be a warning about... There should be a warning bummer about not putting code in modules. Hi, I was solving advent of code. I was solving advent of code in Livebook today, and I noticed that evaluation in Livebook was much slower than in IEX. Here's a simple example. This takes about 15 seconds in Livebook, but evaluates instantly in IEX. I was going to ask about this, but then I remembered Jose saying in some video that code is much slower to evaluate, if it isn't in a module. Indeed, putting it in a module makes it evaluate instantly. Makes it evaluate very quickly, just like in IEX. This really should be documented somewhere. I think this should really be documented somewhere. Right. There should be a warning about code outside of modules being slow. Right, so there should be a warning about code outside of modules being slow. Hi, I was solving advent of code in Livebook today, and I noticed that evaluation in Livebook was much slower than in IEX. Here's a simple example. This takes about 15 seconds in Livebook, but evaluates in less than 1 second in IEX. I was going to ask about this, but then I remembered Joseph saying in some video that code is much slower to evaluate if it isn't in the module. Indeed, putting it in the module makes it evaluate very quickly, just like in IEX. I think this should be documented. Somewhere. Because not everybody will have watched random Joseph Valim videos. Okay. Now, before we post this, is it actually not documented? Elixir Livebook code inside modules. Slow. Fast. Maybe there should be a warning under a cell that it's too long to evaluate or something. Yep, and there should be a warning about code outside of modules being slow. And discussion started. We'll see how this goes in the following days. Okay, back to here. Okay, so we figured out why it was slow. It was slow because it wasn't inside of a module, and the Elixir code outside of modules apparently is 1,000 times slower than inside modules. So we have the solution, and it evaluates in 2 seconds, which is fast enough. What else did we need to do? Well, the other thing we could do is try to solve this mathematically, because this looks a lot like combinations. But thinking about it some more, it's not combinations, so that probably wouldn't help. And there's not much we can do to... Is it? Yes, because we don't really need, the problem is we could probably compute this faster over the entire list somehow mathematically, but I don't think we could do the comparison. I don't think we could integrate the comparison into that solution. So let's just not bother with this. Right. So this leaves what? We can delete the speed debugging section because we don't need it anymore. That didn't delete the actual code blocks. Let's just see that it still runs. Still runs. What can we refactor here? The parsing code is almost identical, but it's not completely identical. Because here, this enum join here is missing from this code above. And then this whole thing returns a single tuple, whereas this returns a list of tuples. And we could, of course, put this into a function and then add a bunch of options to it, but I don't think that's worth it because it's basically 5 lines of duplicated code, and this is just more readable this way. Yeah. Okay. Out of curiosity, what do the stats look like for today? So more people have solved yesterday. And yep, basically everybody who solves part 1 today also solves part 2, which is unsurprising. Today was a very easy day. Okay, and that's it, I think. That's it for today then. Thank you for watching and see y'all tomorrow.